Right, today's experimental setup is relatively straightforward. To do this, we just want to make sure that we can get our probe through these lids and into our styrofoam cups, which is where we're going to put our liquid in. So together, our cups that are nested like this, when we put our lids on, is something we're going to refer to as a calorimeter. What a calorimeter does is that it makes sure that whatever you pour into here, that the thermal energy has a hard time getting out, and the heat flow is very limited to the outside world. And so therefore that the temperature of the liquid inside of this will stay relatively constant because it's insulated from the outside environment. So in many ways, if you have an insulated flask, any kind of thermos, something like that, those are also calorimeters in the sense that they're meant to keep the cold stuff cold inside or keep it hot, depending what it is. So to make our own little home-built calorimeter here, we just need to have a little bit of a hole so that we can get through the lids. If you look in the lids, there's actually some small holes that should work quite well, that you can just push your little temperature probe in. Remember, we want this end of the temperature probe, this one that's coated, to go through. And I can just push it through the other one. If it doesn't go very easily, please just use a sharp object or a knife to push it through. Please don't try to damage the probe in there. Don't push too hard. And so when we put it in here, we just want to make sure that our probe will sit at the bottom of that. I can press it on, and then we can plug in the temperature probe into our Pocket Lab sensor, just into the little foam jack that's in the end of it. So that's all we need for our experimental setup. And then we will come in and we're going to do two different experiments today. One where we mix cold water with hot water, and one where we add washers to hot water to determine their heat capacity.